Good evening, everyone. Welcome at the 24th YR webinar. Tonight, we have a pleasure to host Max Kronborg from Mango Solutions. I'm really happy that the series continues. Last week, we had a very popular talk. We will keep continuing our series up until the end of the year. We will finish at the December 17th, and then we will start back in January at the 7th. So this is almost the last but not the least presentation in this year. My name is Marcin Kosiński. I'm a member of Wire Foundation. I would really like to know where are you all from. So keep writing the cities and countries on the chat. If you have any questions or would like to be a presenter, also please give us a message there on the chat. Today we will have an advanced talk, in my opinion, and I'm really curious to hear more and all the details that Max will present. Max will be talking about mocking in R. This can be a very beneficial issue for multiple use cases, but happy to hear what Max have to say. And from the biography, I can tell that Max is currently having a gap year and working at the Mango Solutions, but he's a computer science student at the University of Bath. And Max is particularly interested in machine learning and currently working on a dissertation aimed at predicting capacity levels on public transportation. So a Renaissance person, an R user, computer science student working at Mango, and will share all the knowledge that he has for today. Sorry for the embarrassing intro, Max. I hope now you can take the floor and go forward. And yeah, I hope we'll all enjoy what you planned for today.
Awesome. Thank you very much. Let's get started. So we will start in PowerPoint. So yeah, like was said, today's talk is about mocking and how you can use that in a few different ways. So I'll just start by just quickly explaining what Mango Solutions is, which is kind of the reason I've been using mocking, or the context for me. So it's a data science consultancy and deliver quite a few different services around data science. In addition to this, they also develop and maintain some software products. So one of these is ValidR, which you may or may not have heard of. So ValidR, just quickly, and I don't want to try and sell this to everyone. I got this from a sales deck, but it's just a background on it. But it's essentially we test R, and we then deliver a guarantee that the things that the client has asked for work, which means they can rely on it to function correctly, which is quite helpful for especially pharmaceutical companies and other companies that need to be able to rely on R as a great language, but to be able to have the security in that even though it's open source, it'll still work. So in producing this product, we have to do quite a lot of testing, as you can imagine. And that's kind of where we've been using mocking. And it's also where some of the concepts I'll be talking about around testing kind of come in. So something like unit testing or test-driven development. So if you move on to mocking, what we'll cover is what it is, why you should use it, and how you can use it in testing and in TDD, which stands for test-driven development. And then we'll take a look at some complex examples that I grabbed from a few situations where I've used mocking for something slightly more advanced and a little bit more complex than just testing. So first off, what's mocking? So the basic version is this with mock function, which kind of lets you redirect function calls. So you can specify a function and that whenever the next code will do something else. So this kind of lets you say, whenever you run into this, do something else. And so you can effectively mock out elements of your code, or if need be, someone else's code. You could also mock out code that hasn't been written yet. So a function call to a function you haven't written, but that you're going to write. So you can kind of mock the result. Or in situations where the things you're replacing are interfering with the functionality you want, or where, let's say it's trying to access something that's not available for whatever reason on your current system or due to some limitation to the way you're working. So originally this was part of the testthat package, which is a very popular package that provides a lot of different helpful functionality for testing, which we'll see a few different bits of. So in my case for validar, it's been very useful. It's how we do a lot of the testing. And it included, I think still does, this with mock function. So what's then happened lately is that mockr is a new package that's kind of been intended to provide just this with mock function in a slightly better way than testthat, because it was a bit it's called experimental, or there were some potentially unknown functionalities in it, and there's some environment differences as well. So if we take a look at with mock really quickly, hopefully you can all see my code. I'll just zoom in a little bit. Maybe a lot, actually. So first off, we'll just import the mockr package. And then we'll define a function, which we can call add3. Which, let's say, given some argument, we'll do kind of what the name suggests, return the input plus 3. So test that this
sorry,
works.
Max, to disturb you. Can we make it a little bit more bigger?
Bigger, for sure. Bigger. Yeah, definitely. Is that good?
Once more, maybe. Maybe once more. Okay, that should be great. Thanks.
Okay, perfect. Make this a bit small. Okay, so just quickly to test this. We see the output we'd expect, which is add3. So we've got this function defined, and if we then define another function which uses this, again with very predictable name, that just will print the output of add3. This, and we just test that one as well. For some reason I can't highlight that. Can do this right. Yeah, don't know why I couldn't highlight that, but it'll be this way then. So if we test this one really quickly, it'll print the output. So the way we can use with mock here is pretty basic, but it'll just illustrate the idea. So with mock, and then what we want to do here is two things. We want to supply the function that we want to mock, and then we want to supply the code that we want to run with the mock. So if we start a little bit backwards here, we'll have whatever we want to mock, and then a comma for separating the argument. And then we want to mock this print add3 function with input 2. And so here, we are going to define how we want to mock this. So we're going to name the function we want to mock. So it'll be the add3 function, which is called by the print add3 function. And so it'll take an argument x, and then this is where we redefine what it is. So in this case, we can add 5. So ordinarily, if we ran this, don't know why I can't highlight that line. That's quite weird. 2 seconds. I found that quite confusing. It's not working. Hold up. Just gonna change something. Okay, I'm actually not really sure what's going on right now. I ran this 20 minutes ago, and it worked. That's extremely strange. I'm just gonna try one other thing just in case. Cool. This is the environment thing I was talking about. So I've swapped now for the testthat version. Actually, this, yeah. So that's kind of the difference. You need to be a bit more careful with environments when you do it this way. So if we just use the testthat version for now, essentially what we've done here is we've said run print add 3, which it'll run. It'll then run add 3, but notice that we've said mark that out and then replace it with this result. So instead of running the function we did define, it kind of detours and runs the other element. So I'll just give you one more example of this. So define one more function, which we'll call add. And if it's got 2 arguments in this case, we'll just define it as x plus y. It's pretty simple. And we're then just gonna steal this and put it down here. And then we're gonna replace it with the add function. So it's gonna be print add xy. And we're just gonna rename our new function as well. So we've now got another function, which is very predictable again. Nope, not that. Like this. Just need that. So we can mark out multiple arguments, essentially is what this is going to demonstrate. So if we do some more mocking here, now we want to mark out the add function that we've just defined. So add is now going to be equal to function. And then what we're the original function that we're mocking has 2 arguments. But let's say that for whatever reason, you really don't care about the second one. You can use the triple dots for this. So you can just say that the result here is going to be x minus 2. And it won't matter what you enter for y. And then we're just going to specify what we want to run and then mark. So it's going to be print add. And we can enter 5 and 7 here. And if we run this, it's just going to output 5 minus 2 and not the 5 plus 7 that you'd originally be looking at. So that's kind of how you deal with the arguments when you're marking things. So that's the basic marking, which I'll just place here. So if you then hop back to the presentation, it should be here. So if we then move on to the Mockery package, is another mocking package which was released actually in conjunction with mock-R. So mock-R's purpose was to replace testthat, or sorry, with mock. Mockery was supposed to, or is supposed to, augment the functionality a bit and to provide some more functionality for doing this mocking. So it provides what's called value factories, which you can use in testing, and well, in a few different ways, actually, both for generating values and also to track function calls and other things. And it also provides something called stubs, which is essentially a simplified version of with mock that works in a slightly different way. So if I just initially demonstrate this value factory, which is called mock. So the way that works quite basically is that you define some function, in this case, let's say, which we'll call m for mock, and it's gonna just make sure we import this first. So using the Mockery package to create a mock element, and the argument here is going to be, well, arguments is going to be the values that it generates for you when you call it. So if we input 1, 2, and 3, and we define this, what we have now is a function that when we call it will output the first element and then the second element and so forth. So if you run this one more time, we get 3. And if you run it one more time, we're going to get an error because we haven't defined quite enough values. There's a way around that, which is using the cycle argument. So if you set that to true, it's you can do it as many times as you'd like, and it's just going to cycle through it. That's essentially it at the base level for this mock. So that lets you generate a few different ways of creating values in things you're testing or as input. So it also works with variables. So if we have an x and a y value, and we define another mark here, which is going to be, again, multiple elements, but let's say it's going to be x plus y. And then the second term will be x minus y. We can then do, I still can't highlight that, which is quite weird. Okay, just won't. So if you run this, it's going to evaluate x plus y first. And if you run it again, it's going to evaluate the x minus y second. And you can cycle that as well. So that's kind of the basic level of mock. What this comes with, like I mentioned, was are a few different ways of tracking function calls and things like that. So what this provides to go along with the testthat package as a test is the function called expect call, actually called. So what this will do is that for a given mock object, so m, you can test how many times that's been called. So we've called that twice since we created it, since this line essentially. So if we run this, we can say we expect that it's been called twice. If we run it one more time, it's now been called 3 times. Oh, but we're missing the cycle, so we just got to add that back in. And then run it 3 times. So if we call this again, it'll basically error and say, no, you actually haven't called this 3 times. And it sort of hooks you up with a way to test how frequently this value generation has been called. I'm just going to drink a little bit of water. So that is mock. So I can jump back in the right place. What we then also have are these stubs. So the way they work is very similar to with mock, except it's something you define before calling the function. So it's not this with mock containing code that gets run. It's a statement you make before running the code. And so the way this works, if you go back here, and stubs, is if we have a function f, which will be use the add 3 of x and, well, x times 2, then by 1, it's going to multiply 1 by 2 and add 3, which is what we'd expect. So the way to use stubs is to call the function and to specify first the function that you're going to run. And then secondly, you're going to specify in quotation marks the function you want to stub out or to mock, depending on how you want to look at it. And that's add 3 in this case. And then the final thing we want here is what are we going to do instead? So we can say add 2 and 2. So whenever we run this with an argument of 1, instead of running add 3 with x for 1, it's going to run add just 2 and 2. So we do this and we run f like this. And at this point, we've actually removed it from the argument, but it'll return the result we've specified here instead. You could go further and plug an m in there or a mock and use it that way as well. But that's sort of the base functionality of stub, which, as you can see, is quite similar to with mock, but I guess conceptually it's a little bit different in that you predefine it, and it's now basically it's still valid as you keep running it. If we hop back to here, and so that's the basic functionality of well, testthat, mocker, and Mockery. So this kind of takes us to how to use these for testing in particular. So we'll just briefly discuss unit testing, which you may or may not know. The idea essentially is to test everything in units. So what you should do is break your code into the smallest possible and simple functions. So instead of having one long script that does everything, you should break each logical step into a function. which then lets you test that. So you can test each segment instead of necessarily the whole thing, which can make it a bit more complex. And then you write tests for each module and you test them separately. And then moving, actually give you a slight demonstration of this. So we're going to write some more functions. So unit testing. We're going to have something fairly simple. So we're just going to load dplyr, or dplyr, whatever you want to call it. And we're going to say that we have a function which we're going to call get2rows, because it very imaginatively is going to get 2 rows from whichever data set we give it, which will make empty cars. So it won't be that generic, but it'll do what we're trying to test. So there we go. So we just want to basically get 2 rows from this data set. So we want where miles per gallon is 21. And we're then going to define another function, which we'll call sum for summary, because I don't want to overwrite any other functions. So I'm just going to, well, we can use data here again. And what that'll do is give us this subset of the data, which will supply to get2rows. Not that one. There we go. With data. So we're subsetting the data. Not that way. So what you could normally do is maybe the way you'd originally written it was something like, and I still can't do that for some reason, which is quite odd, but I can do that. Okay. We'll do this. So you might have written it like this, and then have the output be a summarize of some kind. So mean of weight, let's say. Sorry, this is obviously supposed to be data. So if actually we'd have to do it this way. The argument here would be something like, these are 2 different operations. Obviously, I've simplified it quite a lot, but to do unit testing, you should split these. In real life, you'd probably have something slightly more complex than subsetting 2 rows. But just for the sake of the example here, we're going to do it this way. So define these 2 functions, and sum on empty cars will give us a result. So if you decide to then test this, you could do something like expect a value of, well, I guess this would be a data frame, actually, this output with the mean. But what you're kind of indirectly testing when you come to test the sum function and you want to test for the output is that get2rows works as well. So if some clever programmer somewhere goes in and changes this function so it no longer works, and you run it, then it's broken, and you're going to have 2 broken tests. One will point to sum, and that won't technically be correct. So the real way to unit test this would be to sub out, or to stub out, or to mock out the get2rows function. So just based on what we've done previously, that's fairly simple. We're going to use with mock, and we're going to mock out get 2 rows. It's going to be a function. And we're not going to necessarily name the data 2 specifically, because it's not really relevant here, since we won't be using it. So the way we're going to mock this out is a little bit hard-coded, but we are going to use the value that we get from get2rows when it works properly. You might go about this differently on a normal occasion, but just to make sure we have the same value here. oh, and this is going to be wrong now. So we'll just fix it for 2 seconds while we get the output. So if we steal this, this of course needs to be empty cars. So if we run this and we really quickly steal this, what we're going to do, and what you could actually do as well, if you want to define a different function that runs here, you can make it larger with the curly braces. But if it's just one value, then it doesn't need to be too complex. So we're just going to return a data frame, which is generated from these values, which are going to look absolutely horrible. We're just going to tidy it up slightly, so you can see what's going on. I'm going to put a comment here. So now whatever we put into the with mock function, when that runs get 2 rows, we're going to get this value back instead of what we've gone ahead and broken in the original function. So if we put the sum call in here, what we would expect to see is the same result. Whereas if we run this now, we get the error message because the function is broken. So placing this call with mock in your test in order to sub out the get 2 rows result is kind of a way to neatly separate these units. So you don't get kind of a flow of errors in your test all the way from the one that's actually broken through to everything else. So that's conceptually how unit testing works. If we move on a little bit more, kind of as a component in unit testing or to or supported by, you can do what's called test-driven development. So that's essentially, well, it says it's driven by tests. So the way you do it is you start by writing the test and then you code to satisfy them. So it's a good way to explicitly work towards the requirements that you have for whatever you're working on. Just 2 seconds. So just to make it a bit clearer, you generate the requirements that you need for your modules or your units to pass. Then you write the units or the unit tests. Then you get the test to fail, which is always really easy. You just don't write any code. And then the part where the work actually begins is you start writing the code for the modules. And then because you should have conceptually split this into unit tests at the beginning, you should have then isolated these modules from each other in those tests. So once the test pass, you should be done with your work, and everything should be fine. So we're just going to use an example for this. So some GCDs and LCM computations, let's say. So we'll go and do a little bit of unit testing with that. So for which we'll actually use testthat, which you may or may not have seen. So if you make a new script, and we just need a context for it. So test GCDs and LCMs. We can say that actually in here. So we'll call it function tests. And let's say, so we want a function that computes the GCD of 2 numbers and then one that computes the LCM, the largest common multiple. So we're going to write the test for this. So we are going to make use of testthat blocks to do this, which is a testthat functionality. So we're just going to name this one. So this will be the GCD test, and it's going to contain some code and code that we think will satisfy the requirements we have to this function. So we usually use expect calls for this, or we will, especially in testthat. That's kind of what testthat provides. Or as you can see here, the top 3 actually provided by Mockery, and one is the one we looked at earlier called expect called. So let's say we want to run the GCD function. We want to test that it works. So the first thing we'll do is we'll test that the output from GCD. Actually, no. The first thing we want to test, let's say, is that GCD is actually a function. Pretty simple. Then we'll come up with another test, which will be something like checking that the data types are correct. So expect type. The reason I use expect is for the first one because it's been superseded or improved on by expect type and expect class. Is that for some data types it doesn't work. So I'm leaving the top one as expect is because that'll work, and then the proper way to do this would be expect type. So the GCD of two numbers, we're going to use an example which for which I know the answer. So 270 and 192 is well, either way, we know what the data type should be, but we'll continue to use this for the example because we know what the result should be. So this should have a type double, and we're then also going to check the actual output. So we'll use an expect equal, and we use the same results. So 270 and 192, and we're pretty sure the result from this should be 6 as a GCD. So let's say that's how we test the the GCD works. We're then going to use, let's do it this way, another testthat block just to check that the well, for the LCM function that we're going to write. So we're going to say that we expect the, and there's already a function called LCM, so we're going to call this one get LCM, which is fine. So we want that to be a function, and just like with GCD, we want get LCM to return a double, and then down here we want it to return the actual largest common multiple, which I also happen to know, 8,640. So here we can do a few more things. So we've checked the function is a function, which makes sense. And then we're checking that the output is double, and we're checking that the result is correct. So at this point, the way we're going to write these functions will be where we compute the GCD, and then for LCM, we use that result to compute the LCM. So the situation that we know we have here is that these tests for LCM will be dependent on GCD functioning correctly, which is not really what we want when we're writing these unit tests. So this is where we can use some of this mocking for our development style. So we're going to use a mock for this because it lets us investigate what's going on a bit behind the scenes. So we're going to have, and actually I'm just going to add this up here. I think it is loaded. That actually will probably be okay. So we're going to mock out we're going to mock something in the get LCM function. What we're going to mock is going to be the GCD function. And the result that we want, oh, sorry, I'm doing this the wrong way around. We're going to use this as a result from the GCD function. So we'll use this for a stub later on. So sorry, what we want actually is it returns 6 because that's a result we're going to need for this test below. That's what we know the answer should be up here. And we'll use it multiple times. So we want cycle to be true. And then we stub it out. So use stub. And this is what I was saying earlier. So we're going to stub out something in get LCM. And the thing that we're going to stub out is the GCD function. And the result that we're going to replace it with is going to be this mock that we've created up here. So what that'll do is just query this one to get the result of 6 every time, which is not that complex. We could have just written 6, but we're going to use this, for example, expect called function to test that things are happening correctly within the function that we write, which will begin to make sense to you once I write it as well. But the goal for now is to write the tests, and then so we have an expect type and an expect equal. What we then also could do is check the arguments that M gets provided with. So the way this works is basically you specify the mock object, and then you specify which call to that function you're talking about, because it might get called multiple times. We're making the same function call, so it doesn't really matter. We're going to just talk about the first one. And then what we want to have happen is that the get LCM request the GCD function for the GCD of these two numbers. So at the point where it calls this GCD function, or tries to, then instead calls M records the arguments, and we know what they should be. So this lets us basically check that things are happening correctly. We can then also say we know how many times this should have been called. So if we use an expect called, we think that M has been called. At this point, we've called get LCM twice. If things function correctly, then GCD should have been called twice. And obviously, M will be called instead. So we're checking this. And then finally, we can check the signature that's called, which is maybe not as pressing at this point because we're checking the arguments as well. But it's another functionality that's provided by Mockery. So we're using these top three functions we get from Mockery. So we think that the call to M on function call number 1 is going to be GCD of X and Y. So that's essentially, those are the tests we're going to be running. So now we then need to run these. And for that, we're just going to have one script here, which will have nothing in it, but we'll call it functions. Functions.r. So we've got that down here. And the way we can then use testthat is, so I'll run that from down here. So actually, I might not have loaded testthat. That's probably a good idea. So testthat has a function called testFile, which will run a file with these testthat blocks in it. So that one is going to be functions. So it's not going to be functions. It's going to be functions tests. And we have these tests in here that we've written. And the one thing we just need to add here, because we want to be able to use the functions we've defined, is we're just going to source the functions file, which will load in the functions. Normally, you might be testing a package, and you wouldn't do it this way, but just for speed of development in this case, we'll do it like this. So if we run this, it's going to run a bunch of tests. It won't be able to load any of the functions, so we're going to get 2 errors, which are basically you haven't written any functions, which is fine. That's exactly what we'd expect. So we can now go about the job of writing these functions. So we need 2 of them. We need GCD, which will take 2 numbers, an X and a Y. And in here is where I'm going to cheat a little bit and just grab the code from here because it's not that relevant right now. It's basically it's a Euclidean algorithm for computing the GCD. Okay. So if we just save this and we run our test one more time, we can see that we have 3 passed tests and 1 failed. And we get a little bit more of a breakdown here. So we've got 3 of them are fine, and then this 1 failed, which is that there's no get LCM function, which is what we'd expect. So what we could probably predict has happened is that these 3 tests have run and they've all passed, which is fine. That's what we'd expect. So we then go about writing our second function, which will be get LCM, which will have, again, take 2 arguments, also X and Y. In this case, what we want is the greatest common denominator is going to be GCD of X and Y, and then the result is going to be X times Y divided by G. So if we run our test again, this will hopefully pass, right? Perfect. So we've got 13 passed tests. Ordinarily, if you're writing a function that is a bit more complex, what you could see happening is that you get fewer and fewer failed tests. But in this case, we're using some pretty simple algorithms, and I stole one of them. So that wasn't really the case. But let's say you define the 2 functions, and and they don't work correctly, you'll get a pass test for the test of whether they are a function or not, but you won't really get passing tests for these two. And so you can kind of build your way up from there until you have something that satisfies these checks that you made. So if we go back to this test script, this bit that we've done here is the unit testing component, but we've used mock and stub instead of the with mock. But essentially what we've done is we've separated the LCM function from the GCD function. So if some really clever programmer shows up and changes your GCD function to multiply x by 4, then we'll get definitely one failing test, because the test for GCD will have the test for the exact value failing. And what we don't want is that the LCM function now fails because it gets an incorrect output from the GCD function. So if we run this again, we only get this one failing test because we've used these two lines to detach the two and to split the modules into units. So that is unit testing and mocking. I do have two more examples that we can go over quite quickly. So I'm trying to figure out how quickly I can write this up. This code I actually have in a file. Sorry, we're running a little bit out of time, so I'm speeding up slightly. I'm just going to steal this. And we'll just go over one example, and then we'll be done. So, and we don't need this either. If we just actually, that'll be okay. We'll do this. And I have got this example from one of the tests we were writing. So I'll just quickly explain it and how it works, even though it's going to take up quite a lot of space on the screen. So the objective here was to test this. It's a package called Cox Robust, and it's got a few different components to it. So one of them is this plot.coxr, which plots the result of a different function in the package that we'd already tested. So that's another way you can go about the unit testing, is to be sure that this works, and then you have to tie them together, essentially, these two functions, because we had to use this. But the goal here is to run this plotting function, and I still can't do that. That's really frustrating. Okay. So if we just quickly look at this and the way it works, which is quite frustrating. So for plotting functions, the way we usually do this is we plot the result, we check that it's correct, and then we save it to an image file. And when we then go about testing it later, we can run it again, capture the image, and compare the two to check that things are still working. So the way you'd maybe normally go about this is to, well, we already have loaded testthat, but we load in the package we need. We create some mock data. So we need a data frame. We need to do some survival analysis. Then we use one of these functions from the package to get an output. And then we want to plot this. And what we get is this setup that you might have seen, which is that you get one plot over here, which is fine. And then in the console down here at the bottom, hit return to see next plot, which is great if you're a person clicking on the keyboard. But when it's an automated test, because they're not interactive, you can have someone sitting there clicking next, and you also can't capture it to an image. So you need to find a way around this. And I will just quickly explain how you can use mocking for this. So this initially took a bit of time and a lot of failures. So what's happening underneath the code is, for example, this par function, which will change the layout on your screen of plots, which you may or may not know about. But if you set this, I'm just going to save the current setup so we can restore it later. And you set the number of rows to see a vector that's 2 by 2. What you're saying is, when you plot things, there can be 2 by 2. Well, you can fill in, let's say, a 2 by 2 grid of plots. So if we make some really simple plots here, we get one plot which is considerably smaller than they normally are, because there's space for more. And if we make some really boring extra ones, they fill in this 2x2 grid. And if I just reset things to the way they were before, what was essentially going on within this plot function is that it was calling par, and it was changing things. It was then using split screen, screen and close screen to set this hit return to see the next plot. So here, what you have to do is you have to use mock to go in. And we don't need this, because then I'll just walk through the different elements. So the code we really need to run is this plot.cogs our output. And then just prior to doing that, we set up a temp file to capture the output. But essentially, this is the code that we need to behave differently. So after debugging your way through it for a bit, you realize that what you need to mock out is, amongst others, par. So what I initially did was I used this function, and I ignored the output, which is what we do with these 3 dots, and then the function does nothing. I just wanted it to stop doing par and changing the way things were being plotted. That gave me a failure, because further on, it was using the function par for something that was actually useful, or at least that I needed it to still do in order to not fail. So what I've done here is that if we're at this place where the argument supplied to it is this and, which I actually don't know what stands for, we return false, because that's the one result it does need at one point in the code, which ensures that it avoids doing the things that I don't want it to do, and it still does the things that the code needs to do in order to function properly. So that's why this call became a little bit complex. And then we mocked out with no effect these split screen, screen, and close screen. So the way this works out in the end, we've already saved this one. So what we do before running it is that we want all 5 graphs. So there's one big graph and then 4 smaller ones in the grid, similar to what you see down here. So we define a matrix to say that we want the big image on top and then the 4 ones below it with the layout matrix. So we set those values, and then when we run with mock, you can see here we basically prevented it from making all these changes behind the scenes, and we've told it, well, we've actually reordered the layout on our own to fit the output that it produces. So in this way, we've managed to use it to make it possible for us to test something in the first place, which is one example of how to use it. And then the other way that we've actually made use of this is a bit more complex, but essentially, in order to test a web scraping package, we needed to be able to redirect the code to search the right files to be able to run these. Well, actually a headless browser and actually, no, it's a headless browser in both cases. So the code needs to access a binary in order to run anything. The issue we had was we couldn't rely on that being installed on clients' machines. So we had to find a way to ship it along with it. And if it can't find the files, it tries to access the internet, which is also not allowed for our product. So the way to get around this is to put the file somewhere that we know of and ship them along with the code, and then use with mock to redirect the lookup for these files. So here we're using with mock, and we basically found out where in the code it tries to look up where these files are that we don't want it to look for and where we want to redirect the code. So this is called, it's a package called binman, and it's the app directory function. So we just apply it with a string here, which is the file path to where we've placed the files. And then we run the line that we normally run. But this ensures that the code checks the right location and the location that we want, and not the location that the package checks, that it doesn't let you choose yourself. And essentially, you have to do this twice. So those are 2 other ways to use with mock. That's not necessarily directed towards testing and the kind of framework you use for testing, but more cases where you have unintended functionality that you want to change in some way, but that you aren't really allowed under the hood of the code to do. through arguments or something like that. So that's another place where mocks can come in quite helpful. It's not always that pretty, and it does take a bit of work, but it kind of gives you a way around some of these things. So that is the end, I believe. And that, yeah, so that takes us to the end. And there's some information from Mango Solutions if you ever want that. Yeah, that's everything. I think I'll hand over control.
Thanks, Max. How do you feel after your live coding? Is it hard to do the live coding? I saw there were small issues at the beginning. Does it makes you more into doing that, or is it that making you very stressed?
I think it can be a bit stressful. So when things don't work and you don't know why, it can be a bit stressful. But I think that's kind of, you have to accept that that's part of it. So for a lot of the training courses we deliver, because we've gone online now to deliver them, you're kind of sat like this in a Zoom meeting with a number of people, and you're live coding, and you kind of get more used to it. But I think something that everyone watching the live coding probably accepts at one point or another is that there will be issues, or there can be issues, but they're usually quite minor. So and it's an interesting thing to do. I think it helps you coding a little bit, because you have to keep a bit more track of things, because you're explaining it while you're doing it as well.
All right, makes sense. I admire that you tried the live coding, and since the flow was understandable, we have the regular flow. We saw that the code was appearing instead of like switching from the slide to slide that was very occupied with the code. So I think that was a good solution. And I see there are a couple of questions on the chat. Maybe let's start with, this one. Is there any popular package that uses mock-R for testing? Have you seen mock-R, I don't know, in tidyverse, dplyr, maybe some other popular packages?
I actually have, well, I haven't looked too much at the testthat packages themselves are using. So we usually write our own for packages. So we don't spend a lot of time looking at the I mean, you could call it built-in testing functionality. I would assume so. So Hadley Wickham wrote he wrote testthat, and then he wrote with mock for that. So, and which has then now been replaced by mock-R and Mockery, which I'm certain that he knows about and has some part in. So I wouldn't be surprised if he's made use of those.
Yeah, probably that's a question, or where to seek for examples. That I think was the intention.
Yep.
Alrighty. When it comes to programming, Max, what is that you do first? Do you write a test or do you write a function? Can you describe pros and cons of both approaches?
So I think I have tried the test-driven development approach a few times. I quite liked it when I first learned about it, and certainly I think it helps you to think about things in a slightly more structured way, where sometimes I kind of jump into the code a bit and start writing some stuff and then figure out other bits that I need. The benefits to this approach in general is, and that's the point to it as well, is that it makes you, well, plan things out, develop requirements, and then once you start implementing different components, because you want to do it in a unit testing approach, you have a tendency to create more, I guess, simple functions and simpler code, because you want to separate it into these modules, which is quite helpful. So I have tried it a few times, and it is quite helpful. But I think sometimes I'm too eager to get started as well, and so I skip it a little bit.
Yeah, I know.
Even then, when I do test-driven development, I find myself going back and adding tests sometimes as I think of new things, which I think is fine. But I guess as long as what you get from it is this improved, more structured approach to it, then that's a good upside.
Okay, I see. I personally do write a function at the beginning, and when I think I'm done, I do a test, but I can understand test-driven development as well. There's a question regarding similarity to injecting the code for SQL for database management. I think this is something similar to what we talked before the webinar. do you see any similarities when you're using mocking in R when it comes to similar approaches in a SQL? Do you have any experience in that?
Not with SQL. No, I don't actually. I haven't stumbled on that. I haven't done a lot of SQL work, I think I have to admit, but most programming languages have something like this. So test-driven development and unit testing are by no means new. They're quite old.
Mm-hmm.
And this idea of mocking and stubbing out things is as well. So I know C has functionality for this, but I think the upside to R and with mock is that it makes it quite explicit, and it's, I think, really easy to use. Whereas my impression is for something like Python or C, you have to
Mm-hmm.
set it up more carefully, I think.
Alrighty, so I think there is, I will just jump to other questions as I see a follow-up. So this is not specific to R, right? Like the mocking is like language agnostic. It appears also in other languages. It's not just an R thing.
Mm-hmm. Yeah. So was that the question?
Yeah, the question is, are there any languages that use mocking? Is it specific to R?
Yeah, so it's very broad. And it's I think it's something like test-driven development came out of extreme programming, which I think was started in the 1990s, well, 1999, I think, or something like that. So it's reasonably old, and it's more of a programming concept that you then go and apply to specific languages. So it certainly exists in a lot of places.
Got it. There's one more from Anna. What is the biggest problem that mocking solved for you?
Well, I actually think it's that first example I went through. So when the way we usually do these things at Mango is that you pick up the package to test it. And in this case, we tested it before and we iterate for each new version of ours. So I had access to the old test and it kind of just said, here's some really weird code and it doesn't really work. And we're not sure that it's the best way to do it. And it was quite hacky and I couldn't even really figure out exactly how it works. So I decided to try and fix it. And it took me quite a while. And the approach I went with is the one I briefly went through here. So it was quite satisfying once I finally managed to work it out and put everything into the same image file. I guess in terms of how big a problem it was for me personally, I guess it wasn't huge, but the satisfaction was actually quite nice.
I see. That's quite an achievement. Yeah, I can understand that. Alrighty. And there's one more. Is there any way mocking could help in data analysis?
That's a good question. I'm not sure. Well, I mean, I was thinking about this earlier actually, kind of. So when I was looking at this mock or M, which is like I think they call it a value factory, this generator, whether there are other ways to use it, and there certainly there are, because you can kind of define how it iterates. So I was thinking there must be ways to use it for data analysis, but I think if you're analyzing specific data, then I guess not so much outside of the testing aspect to like your workflow, because you don't have to test specific values. If you've written data transformation code, you can still employ a testing approach to it, so you can certainly use it there. But I think it would be something like that to verify different things about your data as you step through it, and then potentially mocking out bits to make it into this modular structure. And then I guess usually it would then be applied to where you have actual functions. So I was thinking something like synthetic data generation. If you have to do that, I think it could be quite helpful. Some of these things, but again, it's from a testing perspective, I think.
Okay, so I see. Like R can be used for data analysis, but this part of the ecosystem is rather for testing, checking your code, development.
Yeah.
Okay, I see. Are there any similar useful packages that you use for the development besides Mockr and testthat? Is there anything else that you would recommend that you find handy?
Well, so I think which maybe you know about or not, I think we use Golem quite a lot for package creation. It sort of makes that flow a bit easier, but that's kind of the only one I can really think of. So there's a lot you can use if you're doing specific data analysis, obviously, but in order to structure your development approach, there's there's documentation software or packages. There's this for kind of structuring your workflow, and then if it is a package you're working on, it would be Golem. I'm pretty sure it's Golem. Just to make things a little bit easier, which we use quite a lot when we deliver products to clients that are written in R, like dashboards and things like that. We usually package them up, which is also where a lot of this testthat functionality comes in.
Okay, Max. I think we can call it a day. It's been an hour, and I really appreciate the knowledge that you presented today. In my opinion, that's very advanced piece of knowledge. So as an experienced R user, I see a lot of benefits from that. And to those that do not grasp it at the first glance, I would recommend watching it a couple of times until it clicks, because that's a very useful part of knowledge. And yeah, thanks for coming, everyone. Let's see you next week, the very same day, the very same hour. Thanks, Max, for joining. And if you have any last words, that's the time.
Yeah. All right. Well, yeah, thanks for having me. Thanks everyone for watching. Hope it was useful, of course.
Okay. Yeah. So thanks and good night.